Okay, let's go ahead and talk about ionic compounds now. So, what are ionic compounds? Remember that ions are atoms or molecules with a net charge due to the loss or gain of one or more electrons. Okay, remember that electrons carry a negative charge inherently within them. So, how are negative ions made and how are positive ions made? Go ahead and take a moment to answer these questions. Pause the video and then press play when you're ready. So, negative ions, also known as anions, are made by adding additional electrons. This seems to confuse some students, so let's talk about it. When you add an electron with a negative charge, you're making it more negative. Okay, so don't think of it as strictly numbers, but that you're adding a negative charge. Okay, and how are positive ions or cations made? That would be simply the opposite by subtracting away these electrons. So you're taking away a negative charge. All right, and you do need to remember those names. Anions are negative, cations are positive. Okay, Lewis dot pictures can help us do this. So draw the dot picture for potassium and then answer, is this atom stable and why? And then draw the dot picture for fluorine and answer, is this atom stable and why? Okay, I'll give you a moment to do that. Pause the video, give it a try, and then press play when you're ready. So what we have here is potassium. Its symbol is K. And because it's in group 1, it has one single valence electron. That makes it very much not stable. Okay, so it's not stable because it has that one valence electron, as we saw with the reactivity of the group 1 elements in water. Excuse me. Draw the dot picture for fluorine. Okay, as you can see here, fluorine is in group 17, which means that it's lacking one electron to complete its octet. So again, it is not stable because it has 7 valence electrons. And I bet you can guess what we're going to do next, right, to make both of these stable. Ions are usually stable because they either gain or lose as many electrons as they need to in order to complete their octet. So draw the dot picture for the potassium plus ion, and then draw the dot picture for the fluorine minus ion. Pause the video, take a moment to do this, and then press play when you're ready. Okay, so what we have here is originally potassium has this one electron. When it is transferred or lost, potassium acquires a plus charge, and you show this with brackets and the plus in the top right corner. Likewise, when fluorine, which originally has 7 valence electrons, and it acquires this one here, it will have a negative charge, and you show that similarly with brackets and this minus charge at the top right. It's simple enough. And now this positive and this negative are attracted to each other, and that is essentially what creates an ionic bond. Go ahead and watch this video if you're following along in the notes. This is a great video that explains this very clearly with great animations. Okay. All metals tend to lose electrons to form positive ions called cations. On the flip side, all nonmetals tend to gain electrons to form negative ions called anions. Those are very important things to remember. You should remember where the staircase is on the periodic table. Anything to the right of that is a nonmetal, and anything to the left of that would be a metal, except for hydrogen, of course. So remember these two things. That will help you out tremendously. Before we keep going, let's talk about coefficients and subscripts. Okay, just like in math, we have coefficients in chemistry. This 2 out in front means something special. It means that you have 2 of this NaCl, which is table salt, sodium chloride. It means that you have literally 1 and 2. All right, that's pretty simple. Let's look at this next one, calcium chloride. If you have a 3 out in front, you have 1, 2, and 3 of these formula units of calcium chloride. However, this 2 subscript down here, what that means is that you have 2 chlorines on each of these. Okay, so the 2 here only pertains to the one that it's attached to. In this case, it's chlorine. The 2 does not pertain to the calcium because it's not directly attached to it. All right, this is very important later on as we talk about polyatomic ions. So just remember this. Make sure that you understand this page. All right, lastly, let's draw the dot picture for the calcium atom and the calcium 2 plus ion. Also the dot picture for the bromine atom and the bromine anion. And then combine them to make a neutral ionic compound. Okay, I'll give you a moment to do that. Pause the video, take your time on this, and then press play when you're ready. Okay, so hopefully you've done that. Let's go ahead and talk about the answer here. So for the calcium atom, as it stands in the periodic table, has 2 valence electrons because it's in group 2. When it loses those 2, it becomes the calcium cation with a 2 plus charge. Likewise, bromine has 7 because it's in group 17, 7 valence electrons. It acquires 1 more when it forms an ion. It has a negative charge. If you were to combine these two to form a neutral ionic compound, the only thing that you need to remember here is how many of each do you need? And this one's pretty simple. If you have a 2 plus and a 1 minus, you would need 2 of the 1 minus charged ion to cancel the 2 plus. Okay, this is the idea behind the least common multiple from math. I suggest you use this. The least common multiple between 1 and 2, of course, is 2. So, combining these, I just drew it this way for it to make logical sense. This negative charge takes care of one of the positive charges from calcium, and this negative charge takes care of one as well. So at the end of the day, the formula is going to be CaBr2 because you need 2 bromines for every 1 calcium, and that is called calcium bromide. We'll get to that later, but first, this practice should be very helpful, and that will come later in the module. If you have any questions about this or the practice, let me know. Send me an email. I'm happy to answer your questions. But overall, this is what I want you to know at this point in time.